Welcome back to our class. Today we are going to be looking at uh, the naming of organic molecules. It has been a problem for some students, most especially those because it is a new uh, way of studying. It has been a problem to many students that they find issues with the organic molecules. So today, let's look at how do organic molecules named and how can we be able to get distinctions when it comes to organic molecules. All right, it is m.saidi. Thank you for tuning Thunder Eduke, where you will be able to get distinctions. If you have any question, let me know as the class is live so that we are able to help you out and solve that problem which you have. Don't forget that in March we have education camp, a study camp, which is going to be taking place on 23, 24, 25, 22, 23, 24, 25 maths, math lit, physical science, life science, business, economics. Don't miss out. Start booking now because we have limited spaces. All right, let's start without wasting time. Naming, there are some things which you need to understand before you go completely to naming. Right, naming, we have to know the suffix and the prefix. The suffix of the homologous series, which homologous series, homologous series. Yes. And then you have to know the prefix. Prefix. Prefix, it helps us to understand how many carbon atoms are present in each compound. So when you say meth in science, it means one carbon atom. When you say eth, it means two carbon atoms. When you say prop in science, it means three carbon atoms. When you say butte, I don't know whether I call it boot. Okay, it means four carbon atoms. Pent means five carbon atoms, and then hex means six carbon atom. Hept means seven carbon atom. Oct means eight carbon atoms. Based on our level, those are the eight carbon atoms you're supposed to deal with. So the remaining one, you have to manipulate this. So we call these ones prefix. You understand? So you have to know that when I say prop, what does it mean? It means that a molecule with three carbon atoms. When I say hept, it means that the molecule with how many carbon atoms? With seven carbon atoms. So once you understand that, then let's go to how do we deal with the suffix. The suffix depends on the homologous series. So that the moment you know the suffix and then you know the prefix, then you are able to understand the homologous series, to write the name. All right, the suffix depend on the homologous series. For example, we can have the alkane. Alkane, its suffix is this, which is equal to ane. Alkene, its suffix is ene. You see, and then alkynes, yeah, its suffix is yne. And then we have alcohols, its suffix is this, which is ol. And then we have uh, aldehydes. Aldehydes, yes, its suffix is this, which is al. And then you have the ketones, ketones. Its suffix is one. Yes. And then we have the carboxylic acid. The carboxylic uh, acid. Its suffix, they add this oxygen and oic. So it becomes the oic, this and this. And then it becomes, and then yes, this. So it becomes oic acid. So that's how it ends with. Yes. Then we have what we call the esters. Esters, esters. So the esters is just a little bit different, but because it is a negatively charged or it's a salt, so it ends with eight. Eight, but eight. Whenever you say eight, it means that something which is a salt or it's negatively charged. Therefore, it ends with or OH, something which, like if you say like nitrate, sulfate, those are salts or those are negatively charged molecules. Yes. So I'm not saying that all negatively charged molecules they end with it. In most cases, all salts they are negatively charged, therefore they end with the word H. So now once you know the suffix, now, you know the prefix, which means, I repeat, meth means 1, eth means 2, prop means 3, but means 4. Pent means 5, hex means 6, hept means 7, and then oct means, like the same way a pentagon, hexagon, heptagon, octagon. Yeah, it's the same thing. That's where we get it. Six-sided figure. That's where we get this story from. Now, these are these homologous series with their functional groups, as we say that alkane, it comes from, it end with that, alkene with that, alkyne with that, alcohol because of this with that, aldehyde because of this with that, then ketone because of this with that, and then carboxylic acid because of this and this. So it end up with oic acid, and then esters we end up with that. So what about, is there anything else we have left? Yes. What have we left? We left the haloalkanes. Halo, al, alkanes. So haloalkanes is, it ends with the alkane, but with a halo. Halo is a halogen. Yeah, it's a halogen. Basically, it is a combination of a halogen and alkane. So basically, it will be ending with this. You understand? Yes, but it will be starting with depending on which halogen you have used. If it is bromine, so it's gonna be bromo. If it is chlorine, it's gonna be chloro. If it is fluorine, it's gonna be fluoro. If it is iodine, it's gonna be iodo. So basically, depending on the halogen, the group 7 element you have used. I think I'm clear there. If you have any question, let me know. Mhm. Someone is asking from a different chat, that is this introductory. Yeah, basically is an introductory, but we're gonna be doing some questions concerning about this, about the naming. So I'm just doing this because just to try to bring you the refreshment on this subtopic. But we're gonna be talking about a lot of questions in this regard. All right. Let's continue to the second. Now let's have a simple what? A simple example in this regard. If we say that alkanes, they end with this. So it means that if I have 1, 2, 3, 4, 5. So if you say that 5, 1, 2, 3, 4, 5. What does 5 mean? Yes, you have to know that 5 means our prefix 5 means pent. So I will come here and I say this is pent. Don't forget to put the hydrogens because I explained that before. Pent. But now pent, it is an alkane. Therefore, we add this. Now, the prefix combined with the suffix, then you're able to form the main chain. So it's going to become pentane. Why is it pentaene? Because it is single bond throughout. Yeah, this molecule is single bond throughout. What about if I have, what about if I have, yes, yeah. What about if I have one, two, three, four, and then now I have a double bond there. So it means in this case, I'm gonna say, I'm gonna say one, two, three, four. So four we said is but it's having a double bond, which means an alkane, you see. Yes, it's a double bond. Therefore, I'm going to add that ene, because we say that it ends with ene. But now, what is the position of this double bond? So it's 1 2. If I count from this side, it's 1 2, so it remains the same way. So I put 2, so it becomes but 2 in. Yes, I think I'm clear there. Then we go to the next one, maybe alkyne. Yes, alkyne. Then I have maybe 1 2 3 4 5 6. Now I have a triple bond there. You understand? The others is single bond throughout. Don't forget to put those single bonds. Yes, don't forget. And then like that. So now, remember we had an introductory lesson. How did we form these ordered? If you have not watched it, make sure that you watch it. Yes. So now we have, okay, this one is gonna be 1 2 3 4 5 6. Yeah, it's gonna be 6. So 6, we say that 6, what does it mean? 6 means hex. So if it is hex, I will come back here and I say that hex is equal to 6. But I have a triple bond, which means an alkyne. What is alkyne? The suffix is hex. The prefix is hex, but the suffix is yin. So therefore, I'll come here and I add the word Y-N-E. But what is the position of this triple bond? The position is 1, 2, 1, 2, 3, 4. So I can't go with the 4 when there is 2. Therefore, I'm going to take that direction. So I'm just starting with a simple, but we're going to talk about the more complex one. So it becomes 2 in. Yeah, now we go to the next question. We got the next question where they're asking another. What about now? We are done with alkane. What about alcohols? Alcohols, remember that these molecules, we can have branches and stuff. We're going to look at those branches. We're just looking at the basics for now. Then are saying that alcohols have 1 2 3 4. Alcohol, if for example I have the functional group there, so I have hydrogens, yes, like that. So how do we name that? So alcohol is 1 2 3 4. So 4 is but, so it's gonna be but. But now you need to know this, as I told you last time, that that apart from this, apart from that, yes, the remaining ones, we don't stop with meth. We stop with methane, like that. Ethane, butane, pentane. Yes. And then you talk about hexane, and then heptane. Yes. Octane. So you stop there. You understand? But if it is alkane, alkene, alkyne, you stop here, the way how you see them here. But if it is other molecules, then you stop here. So in this case, we're gonna say that this is an alcohol. So I'm not going to say I'm gonna say butane. Butane. Then I'll add the ending or the suffix, which is the ol. You see, ol. So I'm gonna add it there, and I say all. Yes. Now, what's the position of the functional group? It is on carbon atom number 1. So I'm gonna say but 1 all, butane 1 all. You understand? Yes. So what if it is here? What if it is here? And then this is a hydrogen. What if it is there? So it's still the same story. I will say 1, 2, 3, 4. So it's gonna be butane 1, 2, 1, 2, 3. So I have to go with the 2, 2, all. So that's how we name it. Now let's go to another question or more complex. As we continue, you will be able to understand this better. Huh. All right. Let's go to the next question, whereby we are saying that um so alcohol is done. Remember, we have primary alcohol, secondary alcohol, tertiary alcohol, all those ones. Aldehydes. How do you name aldehydes? Aldehydes, they don't have position. One, two, three, four, five. Maybe the functional group is there, and then hydrogen there. The remaining ones we put hydrogens. Make sure that there are four on each. There are four on each. So basically, it's like that. Mhm. So now it's 1, 2, 3, 4, 5. So 5 is pentane. Ne? But because it is an aldehyde and with what? It end with the al, whereby I'll come here and I say pentanal. So basically, that is how you are supposed to name it. Yeah. So now let's go to the next subheading. What does it mean to say a keton? Ketones are sisters and brothers of aldehydes. So ketones, yes. Ketones, you say 1, 2, 3, 4, 5. Same functional group, but now it is in the middle. It could be either way, but it must be between carbon atoms. So in this case, I will say that 1, 2, 2, yes. Yeah. So one, yes, this oxygen is double bond. So in this case, I'll say 1, 2, 3, 4, 5. So it's gonna be 5. Therefore, I'll say pentan. But now the functional group is on carbon atom number 1, 2, 3. 1, 2, 3. So it's on carbon atom number 3. Therefore, I will say 3. And then I add the suffix for ketones, which we say that is on. Therefore, it's gonna be on. So it's gonna be pentane 3 on. That's how we name the aldehyde, the ketones. Then now we're done with the ketones, aldehydes, carboxylic acids, esters. Yes. So now, what about carboxylic acids? Carboxylic acids are also simple. How do we name them? We name them by saying that 1, 2, mhm, 3, 4. For example, and then I have oxygen there, and then I have another oxygen there, and then I have the hydrogens throughout. So now I'm gonna say 1, 2, 3, 4. So sorry, 4 is gonna be butane, and then now remember it is ending with oic acid. Where is it? Oic acid. Therefore, I'll just add there buta. I add oic acid. So it becomes butanoic acid. I think I'm clear there. Then after that, we have esters. Esters, esters. For example, you have one, two, three, four, five, six, and then now I have a molecule there, whereby I have that there. Yes, let me just do it like that. Yeah. So now it becomes one, two, three. This one comes from alkyl because the oxygen is attached to carbon atom with a single bond. Where oxygen is attached with a double bond, it means that it becomes from a carboxylic acid. While this one becomes come from alcohol. Alcohol. Yes. Once I understand that, now I'm able to write. So it means that this one is one, two, three. So it's gonna become uh 1, 2, 3, which is methyl. Did I say methyl? Three. Propyl, propyl. YL means a side group. And then 1, 2, 3, which is propa propa no wait. So remember we said that esters it end with oet. See, it end with the oet. So that's how we name it. And then lastly, then we go to our activities we always see. Just this is just a recall so that we can do our activities, the one you do in the classroom, which some of them they're challenging, so you'll be able to understand them better. So alkane, they are derived from alkanes. So if I have 1, 2, 3, 4, 5, and I have a bromine here, then I have the rest. Here I've not talked about side groups, branches. I've not talked about them, but we'll see more examples when it comes to the questions. So now we say 1, 2, 3, 4, 5. So it's gonna become 5 is pent, because it is an alkane, therefore it's going to end with A N E. So it's pentane, but it has a bromide as a side group. So it's going to become 1, 2, 3. Bromine is on carbon atom number 3. If I count from this side, 1, 2, 3, still is the same thing. So it's going to be 3 bromopentane. So that's how we name it. Let's go to some of the questions and we see what do they have to say when it comes to this? What do they have to say? All right. These are a simple. This is a simple recall, which means that these were isomers. We saw these isomers that structure isomers, same molecular formula but different structure formula, meaning that different structure formula. But if you write the molecular formula, it becomes the same. For example, CH, maybe CH 6H12. So this compound, it can be having different isomers if you arrange it in space. Yes, for example, it can be 1, 2, 3, 4, 5. Yes, 6. It could be a straight chain. It could be 1, 2, 3, 4, and then I have it has a side group. It can be 1, 2, 3, 4. I have another one molecule there. You see, all these are isomers. So that's what it means, that if you arrange them in space, they form different structures. You understand? Yes. That's why we call them isomers. Anyway, structural isomer. So we have what called a chain isomer, the positional isomer, and the functional isomer. Chain isomer, the main chain changes, and you have like these side groups. Position isomer, you change the position of the functional group. Yes, for example, it was 1, 2, 3, 4, 5, and then this one is here is a triple bond. Now in the second one, say 1, 2, 3, 4, 5, then you make it to be in the, you see, you have changed the position of the functional group, therefore it becomes positional isomer. Yes, it was a primary alcohol, it becomes a secondary alcohol, it is a position isomer. You have changed the position of the functional group. Then you go functional isomer. Here you change the function, the functional group. For example, aldehydes and ketones. Yes. And then esters and carboxylic acid. So basically, that is it. So let's go to questions and we see. Yeah, let's go to questions. Someone is saying from another chat that organic chemistry is easy. Yes, organic chemistry is easy, but sometimes when it comes to the questions, it tends to be a little bit difficult. All right, let's go through this together. Yeah. All right. I hope you can see it better. Hmm. Saying consider the organic molecule, organic compound represented by A, B, A to F in the table below. They're saying that mm, write down before you start doing anything. First, identify the functional which functional group is each or which homologous series is it. So now we're saying that this is an alkane, ne? And then this one because of this, yeah. So this is an aldehyde. Let's identify together. If you see it and you couldn't get it right, then it means that something is still missing. And then now this one is a haloalkane. Haloalkane. And then this one is a keton. Is a keton. You see? Now write down letters that represent the following: an aldehyde. You see, you have already said it. So it becomes simple for you. So it becomes P. Compound which has the carboxyl group bonded to two carbon atoms as bonded to two carbon atoms. The carboxyl group is bonded to two carbon atoms as its functional group. So they're looking for you basically where is it? In this case, they're saying two carbon atoms. You see? Yes. It's not one carbon atom because this and this, they could be the same. But in this case, they're saying the carboxyl group is bonded to two carbon atoms. Therefore, in this case, it's going to be the keton because once you draw a keton, you'll find it like this. You see? It's bonded. You have another carbon atom this side and you have another carbon atom that side. So that's what they are trying to say. So the answer becomes D. Write down the IPAC name of C. Where is C? Okay, let's try to see is a haloalkane. So when you're naming it, we have to bring it out. It is a haloalkane. Okay, let's name it out and then we see haloalkane C. Can you name it? People who are on live, can you name it? Yeah? Are you willing to get the same thing I'm going to get? Okay, let's go. They're saying that it is, let's find the main chain before you do anything else. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I think the parent chain, it has 5. Therefore, I will say because it has 5, so we're going to make this one to be our main chain. Ne? So because it is 5, so we're going to say pen, pent. All right. So now it means that now this becomes a side group. Look, this becomes a side group. So if that becomes a side group, now let's find out. So I have this one on carbon atom number 1, carbon atom number 2, carbon atom number 3, and the carbon atom number 4. 1, 2, 2. So it's going to be 1, 2, 3, 4. And then if I count from this side, the first one is on carbon atom number 1, carbon atom number 2, carbon atom number 3. Are you seeing? So carbon is not number 1. Carbon atom number 2, ne? Carbon atom number 2, carbon atom number 3, carbon atom number 4. So this side, the direction is the same, and this side, the direction is also the same. Is it clear? Yes. So now let's name it. So it's gonna be, this one is gonna be 1, 2. So I have the bromo on carbon atom number 2. So I will say bromo is on carbon atom, so it's gonna be 2 bromo. And then now chloro is on carbon atom number 3, 3 chloro. And then carbon atom number 4, I have a methane there, 4 meth. Meth is one, sorry, meth is one carbon atom, ne? Which means one carbon atom, meth. And then because it's a side group, therefore I'm going to say YL. So it becomes methyl. You see? So if it is a methyl, therefore it's going to be 2, 3, 4. Ne? Cool. Now, because this is an alkane, haloalkane, therefore this one is going to become pentane. Now, we have now to identify which one is the which one goes as the alphabetical order. A, B, C. So B is first, C is the second, D is, M is the last. Therefore, I will say that the name will be 2 dash bromo dash 3 dash kiroro dash 4 dash methyl pentane. So it's going to become 2 bromo, 3 chloro, 4 methyl pentane. Have you got it right? Did you get it right? Yes, if you got it right, let me know. Let me know. Let me know if you practiced it and you got it right. Then it means that you are getting there. All right, let's go to the next question. The next question is saying that write down the structure formula of compound A. They're saying compound structure for 2,2,4 trimethyl hexane. Let me use this. They're saying 2,2,4. Okay, let me check. 2, 2,2,4 trimethyl hexane. 2,2,4 trimethyl hexane. Yes. So it's like that. So now let's draw it. Let's draw together. As I'm drawing, you are also drawing. Then you will be able. So the first one is the main chain, hexane. 1, 2, 3, 4, 5, 6. So I've got it. So at least I've got it right there. Then they are saying that 2, 2. So it means that if I count, this is 1, this is 2. So it means that it means that if it's 1, this is 2. It means that this, the first methyl is going to be there. And then the second methyl is also going to be there because they say 2, 2. But now I don't come back, I don't count from this side because I've already counted from that side. Therefore, it's going to be 1, 2, 3, 4. We have another methyl on carbon atom number 4. You see? And then now they're saying trimethyl 1, 2, 3. The first methyl, the second methyl, both on carbon atom number 2, and then the fourth methyl on carbon atom number 4. And then the longest chain or the main chain is 1, 2, 3, 4, 5, 6. So basically, that's how we draw the structure formula for that compound. Guys who are listening, are you getting it right? Are you getting it right? Yes. If you are getting it right, it means that we are together. Yes. Let's go to the next question and then we see. They're saying that write down the structure formula of compound D. They're saying pentane 2 on. pentane 2 on. Let me write it here. Pentane 2 on. Pentane is 5. 1, 2, 3, 4, 5. But they're saying 2. So I can count from this side or I can count from the other side. Either way is cool. Therefore, I will count from this side and I'll say that pentane 2 on is going to be 1, 2. Therefore, I'm going to have the carboxyl group there, and then now I put the hydrogens. Don't forget that each carbon atom is supposed to have 4 bonds. Why? Because it is found in group 4. So you have to know that. So basically that is pentane 2 on. Yes, we go to the next question. They're saying that define the functional isomer. We saw that one before, the same molecular formula but different functional groups. So we said like ketones and aldehydes, carboxylic acids and esters. Those are functional isomers. Then if we go to the next question, write down the letters that represent two compounds that are functional isomers, ketones and aldehydes, carboxylic acid and esters. We don't set any other molecules here. No. So this is a keton. So definitely, do we have an aldehyde there? What did they say? They're saying that write down letters that represent two compounds that are functional isomers. Okay, we come back and then we check and see. Yeah, this is 5. Remember, pentane. So what about this? This is a keton. Keton, we saw it. And then this is an aldehyde. So it means that it's going to be B and D. So the answer here becomes B, B, and D. Yeah, I think, guys, we are getting it right. Don't forget to subscribe, like, and share. Yeah, so that you don't miss out our daily classes. Yeah, free of charge. Mahala. Ne? Ma what? Mahala. Yes. Think we are clear there? We go to the next question. As we don't set new questions, we always set the same questions over and over and over again. So if you want to get a distinction, you just have to practice these questions. You don't understand them. Yeah, you come to Thunder Eduke. You just search that question. The question, you'll find it there. And then you'll be able to get the distinction. Simple. Simple. There are so many people who have been getting distinctions using this channel. Not only in physical science, even other subjects. Because we cater for all subjects. Yes. Right. Let's continue to the next question. They're saying that A to F in the table below represents 6 organic compounds. It represents 6 organic compounds. The first one, I told you that please make sure that you try to identify the functional group or homologous series for each. This one is, I have a double bond, therefore it is an alkene. Here is butanoic acid. We say that oic acid, it is a carboxylic acid. We have C. This one is a keton. Keton. And then D, we don't have any double bond, so it becomes alkane. Yes, this one is alkene. Well, this one is alkane. Name the functional group of compound B. These are carboxylic acids. Yes. Homologous series of 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 compound C. These are formals, ne? Yes. So it's a keton. Then they're saying that write down the IUPAC name of compound C. IPAC name of compound C. Yes. Okay. Let's look at compound C. Yeah. Okay. Someone said that organic is simple. It's simple if you practice. Now here's compound C. Ne? Compound C. Can you write it for me as you are writing? I'm also writing so that we can get it right, both of us. Ne? Yes. If you get it right, then it means that you are able to understand what your teachers are teaching you. All right, let's start. Find the longest chain. One, two, three, four, five. Do you think that's the longest chain? I don't think so. One, two, three, four, five. Cool. One, two, three, four. Not one, two, three, four, five, six. So the longest chain has six carbon atoms. Did you identify it? All right. So six carbon atoms. So it's going to become hexane. All right. So it means that this is going to be our longest chain. So it means that now the remaining ones are going to be side groups. So this is going to be a side. Where is the functional group? The functional group is there. I see. Yes. So now it means that I have to follow the functional group before I consider the side group. 1, 2, 3. It's on carbon atom number 3. 1, 2, 3, 4 is on carbon atom number 4. So I can't go with the 4 when there is a 3. So it means that now this is gonna be 3 on. So it's gonna be hexane 3 on. Cool. Now since I've used this direction, therefore I'm gonna make this one a side group. So it's gonna be 1, 2, 3, 4 because it is on carbon atom number 4. So I will say that 4. How many carbon atoms are here? Is 1. And one carbon atom we said it is meth. So meth, I add the word meth, but because it is a side group is indicated by YL. Therefore, I add YL. So it becomes methyl. Methyl hexane 3, methyl hexane 3 on. That is the naming, the IPAC name of that. I think you got it right. Ne? Yeah, I think you got it right. The next one is um, the next one is write down the APAC name of compound D. Now let's go to compound D. They just make these things to look complex, but in actual sense, it is air. Yeah, if you are well conversant with this, this is air. Yes. Okay, let's find the longest chain. You see, 1, 2, 3, 4. I don't think so. 1, 2, 3, 4, 5, 6. You think so? 1, 2, 3, 4, 5, 6. I think so. 1, 2, 3, 4, 5. So basically, the longest chain has 6. Isn't it? So let's find it. So 6 is hex. But because the single bond, so it becomes hexane. Okay, now let's find which longest chain did we use. So we used, let's go with this. So now the remaining one becomes the side groups. So this becomes a side group, this one becomes a side group, and this one becomes a side group. Yes. So now once I know the side groups, now I will find the position. So this is 1, 2. The first one is on carbon atom number 2. And then if I count from this side, 1, 2, 3 is on carbon atom number 3. So basically, I will go with the carbon atom number 2. So the first meth, I will say meth, it is on carbon atom number 2. And the second meth is on carbon atom number 2, meth. And then the 1, 2, now I continue with that direction. 1, 2, 3, 4. The eth is on carbon atom number 4. I see. So now I count now. I need to know E and M, which one is first? You're gonna say A, B, C, D, E. E is first. You understand? Therefore, I will come here and I'll say 4 ethyl dash 2 comma 2, because there are two of them and it's the same caliber, methyl. Because there are two, then I'll say dimethyl 4 ethyl 2 comma 2 dimethyl hexane. That's how you name it. Simple. Ne? It's very, very simple. Yes. It's very, very what? Very, very simple. Let's go to this question and then the rest we will finish it for the next class tomorrow. Yes. Yes, we still have a lot of questions we can practice. You see, still have a lot of questions. We can't exhaust all of them now. We also have some calculations there in organic chemistry. So we will look at them and then we'll be able to understand each and everything. You are here for this channel to get a distinction. And I'm telling you, you will get a distinction. It is m.saidi. Let's find out whenever they talk about combustion, what comes into your mind? Whenever they say we have a single product, so it's gonna be whatever you are burning, the product is gonna be carbon dioxide plus water. Simple. Then after that, you balance, you put whatever you put. So now it's gonna be compound D. Where is compound D? Here is compound D. So now it means that here you have to condense it. Condense it. How do you condense it? Okay. How many carbon atoms? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So just by knowing the number of carbon atom, carbon is 10. Then hydrogen is supposed to be 10 plus 2. Eh? No, 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 no. 2n. Remember the formula? Sorry. Remember the formula is like this. CnH2n time plus 2 plus 2. So if this is 10, so carbon if it's 10, hydrogen is gonna be 10 times 2 plus 2, which gives me carbon is 10, hydrogen is 20 plus 2, which is 22. So it means that hydrogen is that. So I will just come here and say you can count it, ne? Direct counting. Yes. So it's gonna be 10 plus 10, 22 plus the oxygen. So that is the reaction. So we get a mark here, you get a mark there. And then now you get another mark for balancing the equation. So guys, we are going to stop here. When I come back, we're going to talk about this. There is also this, we like to set these questions which involve boromine. Make sure that you are on Thunder Educ channels. You will be able to obtain a distinction. If you have any question, let me know. As we are always here, don't forget the camp. Make sure that you register and book your space so that you are securing your distinction. Thank you very much. I will see you again in the next class.